we have to remove the queen, and again we have to move the queen in upper of the column. So previous step backtracking, when all rows in a column have been tried, the call terminates and backtracks to the previous call. Pruning. If a queen cannot be placed into a column that is high, do not even try to place 1 onto column I plus 1. Backtrack to column I minus 1 and move the queen that had been placed there. For using this approach, you can reduce the number of potential solutions even more. So we can get the feasible solution. First we have seen the optimal solution, feasible solution, everything we have seen. So we are going to find out the best solution by using this backtracking and 8 queens problem. So these are the steps we are going to see in the backtracking. First place the queen in the left upper corner in the table. First we are here left upper corner here. Next we have to save the attacked position. In chess we are going to place the queen means we are going to place anything means the opposite should not be attacked. So by saying that we are going to move the object into safest manner. The same way here we are taking only the 8 queens, that each and every one should not be attack each other. So you have to save the attack position, move to the next queen which can only place to the next line. Here first I am placed in the first, in the second queen I am going to place here. In simple way we can easily able to understand the placing the queen is shortcut. You can place the queen either in odd column or the even. That means you can place the queen either 1, 3, 5, 7, this is 4, and you can place 2, 4, 6, 8. This is a shortest way for placing the queen in the chessboard. Next you are going to search for a valid position. If that valid position, you can either keep your queen there, or else you have to go to the step 8. Step 8 is what? Place it to the first valid position. Next, fifth point is there is not a valid position for the queen, delete it. Then again you are going for backtracking. Where it is the problems comes, you are going to search backtracking and you are going to again see the problem of the solution. See the solutions of the problem. Next move to the previous queen. Next go to step 4. Again you are going to search for a valid position. Next place you to the first valid position, save the attack position. The queen process is the last stop, otherwise go to step 3. What is step 3? Again we are going to move to the next queen. This is the algorithm. Put queen in the row, because we are going to place the queen in the row wise, in the row any column. Okay, this is row, so this is put queen in the row wise. Next things, for every position the column, okay, which column you are going to place, that is important. For every position column on the same row, the position column is available, place the next queen in the position. For example, you are placing this queen here, first one means next you have to see the column, because in the first column you cannot place the queen 1. Next second row, which column is there, we can check and we can place either here or anything else. Like this we have to place it. Next, if row less than 8, because this is 8 queen, if row less than 8, put queen, because we are going to include row plus 1. Next row, first this row is over, next row plus 1, next row we are going to place the queen. So if it is okay, in success means you can remove the, if it is success you can place, if it is not success again remove the queen and from the position, and again you have to replace the queen in the particular position. This is simple 8 queens problem of the algorithm. What is the recursive method? Put queen recursive. In the function void put queen, it's a number, integer, variable, integer row you are declare. Next you are using a for loop. In column wise, this column is now 0, in column less than square, and column plus plus, we are giving the for loop using. Next, if column an object is created, COL, we are already creating data types, and we have variable name, we are given the column. So if column column equal to available and left diagonal row plus column is equal to available and right diagonal row minus column is available. Okay, this is the if condition. Then we have to check the position in row is equal to column. You have to check in row, you have to check this which position, suppose 1 2 3 4 1 2 3 4. Okay, in the position row, this is a row which column you are going to place. Suppose I am placing first queen in the second column. Next column is not available, it means suppose the column is not available, you are going to column not available means you have to place in some other. So like this you have to go. So it is recursive. Call the function itself, it's a recursive. Once it's successful, then it will come out of loop. So first one is left diagonal we have seen. Next is right diagonal you have to see. Right diagonal is row minus column is not equal to available. If row less than square minus 1, put queen row plus 1. Next thing is print. The solution found means and the queen is available in the column. So you have to check this left diagonal and right diagonal. You have to check queen one, left diagonals or right diagonals. You have to check this one. If you check this one, if it is correct means, if it is not attacked means, if it is attacked then we have to place the queen here. So we have to check both the left and right diagonal. If both the left and right diagonal is not attacking queen, we can place the queen in some other column. So for this we are getting the 8 queen puzzles as 92 distinct solutions we are getting. The solutions that differ only by symmetric operation and rotation reflections of the board are counted as one. The puzzles as 12 unique fundamental solutions. So the fundamental solution. What is the major advantage? See means the major advantage of the backtracking algorithms is the ability to find and count all the possible solutions. This is the main thing. There is a problem in there to find out best solutions, to find out the feasible solutions rather than just one while offering decent speed. If we go through the algorithm for 8 queens, 981 queens moves, 876 positions test plus 105 backtracks are required. For the first solution alone, 16,704 moves, 14,852 tests and 1852 backtracks are needed to find all 92 solutions. So given those figures, it is easy to see why the solution is best left to computer. So for that, according to this 9 queen problem, backtracking is so good compared to brute force approach. So thank you.